Chapter 2, Minerals. 2.1 is over matter. An element is a substance that cannot be broken down into simpler substances by chemical or physical means, essentially anything you would find on the periodic table. An atom is the smallest particle of matter that contains those characteristics of that element. The center of an atom is called a nucleus. It contains a proton and a neutron. The number of protons determines the atomic number and therefore the identity. Electrons are located in regions called energy levels or electron clouds. Atoms with the same number of protons but different numbers of neutrons are isotopes of the same element. The mass number of an atom is the total mass of the atom expressed in atomic mass units. Many elements have atoms whose nuclei are unstable. These atoms are disintegrating by radioactive decay. This is a box from the periodic table. It shows us carbon. You can see the element's name, its atomic weight, the number of protons located in the nucleus, which is also the number of neutrons and the number of electrons, and the given symbol. A compound is a substance that consists of two or more elements chemically combined into specific proportions. When an atom's outermost electron energy level doesn't contain the maximum number of electrons, the atom is likely to form a chemical bond with one or more other atoms. Those chemical bonds are the forces that hold atoms together in a compound. There are three principal types of chemical bonds: the ionic, covalent, and metallic. An atom can gain or lose one or more electrons. The atom then has an electrical charge and is called an ion. Types of chemical bonds: the ionic bond forms between positive and negative ions. Covalent bonds form between atoms that are sharing electrons. Those are generally nonmetals. You will find those on the far side of the periodic table. Metallic bonds form when electrons are shared by metal ions. 2.2 Minerals. There are some 3,000 different minerals. A mineral is a naturally occurring inorganic solid with an orderly crystalline structure and a definite chemical composition. You're going to refer back to that many times, as that is the textbook definition of a mineral. Minerals form by natural processes. Minerals are solids in normal temperature ranges on Earth. They are crystalline. Their atoms or ions are arranged in an orderly and repetitive way. Minerals have a definite chemical composition. They usually are compounds formed of two or more elements. Most minerals are inorganic chemical compounds. They were never living. There are four main processes by which minerals form: crystallization from magma, precipitation, changes in pressure and temperature, and formation from hydrothermal solutions. Magma is molten rock from deep inside the earth. As it cools, it forms mineral deposits. Substances dissolved in water may react to form minerals. That is what a precipitate is. Changes in temperature and pressure can make a new mineral form, such as diamonds forming deep within the earth due to high pressure and temperature. When hot solutions touch existing minerals, chemical changes can also take place and form new minerals. Common minerals, together with thousands of others that form on Earth, can be classified into groups based on their composition. Silicon and oxygen combine to form a structure called the silicon-oxygen tetrahedron. These silicates are made of silicon and oxygen, and they are the most common group of minerals on Earth. The sand that forms on the beaches is made essentially of silicates. Most silicates crystallize from cooling magma. Carbonates are minerals that contain the elements carbon, oxygen, and one or more other metallic element. That's what gives them their different color, those traces of other elements. Oxides are minerals that contain oxygen and one or more other element, which are usually metals. This red here may look familiar. It's probably iron oxide. We commonly know it as rust. Sulfates and sulfides are minerals that contain the element sulfur. They're going to have a distinct smell to them. They are generally shiny, as you can see. And this one right here, galena, is important because it contains sulfur and lead. It's a lead ore, and it is our state mineral. Halides are minerals that contain a halogen ion plus one or more other elements. Native elements are minerals that can only contain one type, such as gold or silver or copper. Those would be considered native elements. 2.3 Properties of minerals. Small amounts of different elements can give the same mineral different colors. For example, rubies and sapphires are both corundum, but they can contain trace elements that give them distinct coloring. We know rubies come in brilliant shades of red, but sapphires come in many different shades. You can see down there the ring on the bottom left. Those are all sapphires. They can come anywhere from clear to blues to purples to pinks, essentially every color but red. Mineral identification. The main physical properties used to identify minerals. The first one we look at is streak. It's the color of a mineral in its powdered form. And this is done by taking the mineral and rubbing it gently across an unglazed tile. The color that it leaves behind is not always the same color as the mineral itself. And so that gives us a clue as to what the identity of the mineral is. Luster is used to describe how light is reflected from the surface of the material. We say it's metallic or non-metallic or dull. Crystal form. This is the visible expression of the mineral's internal arrangement of atoms. Diamonds come in a cubic structure, which is allowing them to be cut into light reflecting, brilliant, pretty rocks. Quartz comes in a triagonal hexagonal structure. Muscovite is monoclinic. It flakes off. We'll see that when we do our lab in class. And topaz is this ortho. Hardness is a measure of the resistance of the mineral to being scratched. You can test hardness by rubbing one mineral against another of a known hardness. One will scratch the other unless they have the same hardness. The Mohs scale consists of 10 minerals arranged from 10, which is the hardest, to 1, which is the softest. On the Mohs hardness scale, you can see that diamond is the hardest mineral. And that's not saying that that's the hardest substance on Earth, but it's the hardest mineral on Earth. Next comes corundum. Remember we said that our rubies and sapphires, they have a hardness of 9. That means that if you had a ruby and a topaz and you rub them together, the topaz would come away scratched while the ruby would not. Same thing with the diamond. The diamond would cut the topaz and the ruby. You can see over here on the right we have a streak plate, the same streak plate that we use for doing the colored streaks, a knife and a steel probe, glass slide. So when we say that a diamond can cut glass, that is true. Copper coins, fingernails. At the bottom there, gypsum and talc are some of the softest minerals. You can actually just scrape them with your thumbnail and they will powder off and you can see them. Some of the key points of the hardness test. You choose one mineral to be the scratcher and one is going to be the scratchy. We'll pick a smooth, flat surface to scratch. After doing it, you wipe the powder away to confirm that the scratchy really got scratched. If it did not get scratched, switch the two rocks and compete. Cleavage is the tendency of a mineral to cleave or break along flat, even surfaces. Minerals may have cleavage in more than one direction. Remember that cleavage is the same no matter what we're talking about. Cleavage means crack. So there's cell cleavage. So when a cell is dividing into two, it creates that cleavage furrow. Rocks have cleavage. It's where they split apart. Minerals cleave. And there's always the plumber's cleavage. I don't need to explain that one. Muscovite, for example, is going to cleave in one direction, which means it flakes off. Cleavage in two directions, like our feldspar, you're going to see these nice squared box type shapes. Cleavage in three directions, like halite or rock salt, you'll see cubes. And then calcite has cleavage in two directions, but it's offset. That's a really fun one we'll look at in class. Here's some more examples of cleavage. You can see the different shapes that are formed. Fracture is the uneven breakage of a mineral. Most minerals that don't cleave are going to be said to fracture instead. Examples of fracture, there's a conchoidal fracture. and that's going to break in a scooped out bowl shape like a conch or a sea snail. There's Hackley fracture. It has irregular sharp edges. And then there's splintery, which breaks into long, thin needles. We have some mineral samples that we'll look at in class when we do our lab, and you'll be able to see each of those. When it fractures, you will not find any flat, even surfaces. As you can see in all of these samples, they're all very rough. There's no flat surfaces there. And then density. If you don't know what density is, you will remember it for the rest of your life because of this. This is a property all matter has. It's just the ratio of the object's mass to its volume. Now, the way you remember this, if you don't already know it, density equals mass over volume. So we write it D equals M over V. Now, here's the remembering part. Mrs. Ramsey loves to teach density. I love teaching you mass over volume. But you guys watch me do it, and you don't like it so much. But you'll never forget it, because when you see that, there's your M, and there's your V. And there you go, there's density. Some minerals can also be recognized by other distinctive properties, such as smell, feel, color. Now that one's tricky because it's not reliable, but in some instances it can be used. Miscellaneous tests that you can do on a mineral. The acid test, this one's a little more dangerous. You're going to dilute hydrochloric acid and put a few drops on it. If it is a carbonate, it will actually fizz. Some of them have a smell. Sphalerite will give off a rotten egg smell when streaked on the streak plate. Note, pure sulfur doesn't smell like rotten eggs. It does have a little bit of a smell, but it doesn't smell like a rotten egg. Magnetism. Magnetite, when it's a lodestone form, it will actually pick up paper clips. Taste. Now this one's very important for you to listen. Do not taste the samples. Halite is a rock salt and it will taste salty. I will let you know if and when there is a sample you can taste. It's not required because some of those samples have been tested with acid to see if they're calcite. They look very similar. And then the fun one is fluorescence. Some minerals, mostly the forms of calcite, will glow in fluorescent colors under a UV or black light. Fun fact, mica probably comes from the Latin word micere, which means to shine, and refers to mica's appearance. Muscovite, which is a common type of mica, was named after the old Russian state of Muscovy. In the 1300s, it was common to use mica as a substitute for glass, so it was called Muscovy glass. Biotite is another common type of mica. It's the pretty golden black one. Remember, those are the two that we will look at that flake off. They show that cleavage in a single form.